Imagine the following problems: pollutants dumped in a pond, oil spilled in the ocean, a fire in Southern California, a drought in Arizona, and an increase in the number of stray cats in a neighborhood. What do all of these problems have in common? They all influence the environment around them and have the potential to change the dynamic of the environment. Within the field of environmental science, there is a branch, known as ecology, which is used to study these types of environmental problems. Ecology is defined as the study of the distribution and abundance of organisms, the relationships between organisms, and the interaction between organisms and their environment. Although all of these problems are similar because they influence the environment, they also have one major difference: the scale to which they influence the environment. Some environmental problems are localized and only influence one species, while other problems influence a whole ecosystem or even the whole world. Due to the variation in the effects of environmental problems, the field of ecology has been divided into different branches based on scale. Population ecology is the study of the interactions of a single species with other members of its species and the species environment. Population ecology deals with problems that are on a smaller scale and influence a single species within the environment. An example of population ecology would be a study on the distribution of herds of deer. Community ecology deals with slightly larger scale environmental issues and is the study of the interactions between multiple populations of species within a specific ecological community and how these populations interact with the environment. An example of community ecology would be a study on how two species of turtles utilize and partition the same habitat and food sources. For an environmental problem that includes multiple communities within an ecosystem, ecosystem ecology would be used to study the problem. Ecosystem ecology is defined as the study of the interactions between organisms from multiple communities within a larger region. An example of ecosystem ecology would be a study on how a fire has influenced the species in a specific habitat. Although many scientists study environmental problems at the population, community, and ecosystem levels, there are some environmental problems that are even larger in scale and can influence the whole planet. For these types of problems, the field of global ecology would be used to investigate answers. Global ecology is the study of the interactions among the Earth's ecosystems, land, atmosphere, and oceans. Global ecology is very important because it is used to understand large-scale interactions and how they influence the behavior of the entire planet, including the Earth's responses to future changes. In recent years, there has been an increase in the field of global ecology due to the influence of globalization. Globalization is defined as the increase in the interconnectedness of human activities, ideas, and cultures. In the past, regions of the world were more isolated from one another and did not see how their actions influenced people in other regions. With the increase in globalization, especially the increase in travel and the sharing of ideas, people are becoming more aware of how their actions are influencing people and the environment outside of their immediate area. This awareness of others is important to the field of global ecology because as awareness increases, there will be a higher demand for research that focuses on investigating and solving worldwide environmental problems. There are currently 4 major environmental problems that are occurring on the global scale. The first environmental problem is habitat destruction. Habitat destruction is when a natural habitat is altered in a way that makes it no longer possible for the habitat to support the species originally found in it. Habitat destruction can include land modifications such as deforestation, urbanization, converting land for agricultural use, dam construction, and strip mining. As habitat destruction increases, there is a reduction in the amount of available habitat which wildlife rely on for survival. The second major environmental problem that is occurring on a global scale is the harm caused by invasive species. Invasive species are species that have been transplanted from their original location to another location and have negative effects on the native organisms, environment, and economy of their new region. With the increase in globalization and world travel, the prevalence of invasive species has increased. The third major environmental problem is the decline of population densities. Populations of many species have been drastically reduced in recent history due to their use by humans. Some species of trees have been over-harvested for timber, and the populations are now rare and near extinction. This has also happened with animals that have been heavily hunted for food, medicinal properties, and sale, such as tigers and whales. The fourth major environmental problem that is occurring on a global scale is pollution. Pollution is the act of releasing a contaminant into the soil, water, or air. Although most pollutants are released in a specific location, pollution as a whole is considered a global problem because the effects of the pollutant often reach farther than the immediate area where the pollution occurred. Pollution is a very important environmental problem that requires immediate action because as a result of an increase in pollution in recent years, there have been changes in the entire climate of the planet.
If the population continues to increase at its current rate, we will not be able to maintain or raise the global standard of living without risking the destruction of the environment. It took hundreds of thousands of years for the world population to hit 1 billion. In comparison, it took only 123 more years to reach 2 billion, and merely 33 years to hit 3 billion. Currently, the world population increases by 1 billion people every 13 years. Every second, an average of 4.2 people are born and 1.8 people die. That's a net gain of 2.4 people per second. Today, the population totals almost 7 billion. By 2025, it is estimated to reach 8 billion. By 2050, there will be 2.5 billion more people on Earth than there are today. That's an increase equal to the entire world population in 1950. The demand for fresh water increases as the population's size increases, but there's only so much fresh water on Earth. By 2025, it's estimated that more than 1 in 3 people will be affected by water shortages. In more than 1 out of every 2 developing countries, the population has been growing faster than the food supplies. To feed the projected population in 2025, we will have to double food production over current levels. Even if we are able to double our food production, it won't come without a cost. Increasing food production creates a chain reaction of ecological disruption. The problems with climate change will only grow worse as the population increases. The higher the population, the greater the demand for oil, gas, coal, and other fuels that create greenhouse gases. Though the population in developed countries represents a small amount of the world population, they consume fossil fuels much faster than developing countries. In the United States, each person contributes about 1,644 tons of carbon dioxide. That's 5 times higher than a person in China, and 91 times more than a person in Bangladesh. Though levels of consumption differ greatly around the world based on economic status, the higher our population, the higher our total levels of consumption. What can we do? Lower levels of unnecessary consumption in developed countries, and find sustainable solutions to meet increasing demands on food, water, fuel, and other basic resources. Provide universal access to family planning services, contraceptives, and information. Empower women. Give women access to healthcare, education, and birth control. Give women the right to control the size of their families. Democracy cannot survive overpopulation. Human dignity cannot survive it. Convenience and decency cannot survive it. As you put more and more people into the world, the value of life not only declines, it disappears.
Over the past 200 years, humans have started to have a measurable effect on the carbon cycle. Part of this is due to deforestation. If we look at biomass per acre, forests contain the highest density of biomass on the planet. So deforestation removes carbon from biomass, and where do you think it goes? Some of it is turned into wood and paper products, but a lot of it has gone into the atmosphere. However, an even bigger change to the carbon cycle has occurred as a result of the widespread use of fossil fuels. Burning fossil fuels releases carbon dioxide, also known as CO2, into the atmosphere. This adds carbon that has been out of circulation for millions of years directly to the atmosphere. The immediate result of these human activities is that in the past 200 years, the concentration of carbon dioxide in the atmosphere has dramatically increased. In 1800, the carbon dioxide concentration in the atmosphere was about 280 parts per million. But the most recent readings from June of 2012 measured the concentration at 395 parts per million. Scientists measure carbon dioxide in the atmosphere in parts per million, which is another way of saying, out of every million molecules of air, how many are carbon dioxide? If 280 molecules out of every million are carbon dioxide, then the air has a CO2 concentration of 280 parts per million, or ppm. In 1958, scientists started taking direct measurements of atmospheric CO2 on a continuous basis. From these direct measurements, we know that the concentration of carbon dioxide has been steadily increasing year after year for the past 54 years in a remarkably regular seasonal pattern. The pattern is so steady that CO2 levels have reached a new high each May for the past 46 years straight. It's also very predictable. In fact, I'll predict that in May of 2013, CO2 levels will rise to a new peak level of 398.6 ppm, plus or minus 1 part per million, and that CO2 levels will break above 400 ppm for the first time in more than a million years in either April or May of 2014. To check the accuracy of these predictions, or to just check out the data yourself, you can go to this National Oceanic and Atmospheric Administration website, and you'll see the latest atmospheric CO2 data. So what does this mean? Why should we care that the concentration of carbon dioxide in the atmosphere is steadily increasing each year? The reason is carbon dioxide is a greenhouse gas, which is a gas in the atmosphere that absorbs infrared radiation from the Earth and slows the rate of heat loss. The three major greenhouse gases in the Earth's atmosphere are water vapor, carbon dioxide, and methane. These greenhouse gases act like a giant blanket for the Earth, helping it to retain heat. And when the concentration of greenhouse gases goes up, it's like adding another layer of blankets. When this happens, then global warming, or an increase in the average worldwide temperature caused by higher concentrations of greenhouse gases in the atmosphere, is the logical result. Now this may sound theoretical, like I'm guessing that if CO2 levels rise, then we expect the Earth to get warmer. However, the fact is, we have actual scientific evidence that when CO2 levels rise, so does the average temperature of the Earth. These two graphs show the correlation. The top graph shows the carbon dioxide concentration in the atmosphere, and the bottom graph shows the average global temperature. Both graphs cover the 800,000 years preceding 1950. As you can see, every time CO2 concentration spiked higher, the temperature went up too. And when CO2 levels bottomed out, so did the temperature. Now, like almost all true scientific data, there are some small anomalies, and the data doesn't always match up perfectly. But even with these small imperfections, this is one of the closest correlations that you will ever find in the natural world. The history is clear. In the past 800,000 years, whenever CO2 levels rise significantly, the temperature rises too. There's one other interesting thing to point out about past CO2 levels. In the past 800,000 years, the concentration of CO2 never rose much above 300 parts per million. That is, until about 100 years ago, when we blasted right through the 300 mark on the way to our present level in 2012 of a little over 390 parts per million. So what will happen now? There are lots of different estimates and claims that many people make, but in the past century, the global temperature has risen 1.4 degrees Fahrenheit. That may not seem like a lot, but the temperature has been rising at a faster rate in the last few decades. In addition, we have 800,000 years of history that show that temperature is highly correlated to atmospheric CO2 levels. We are continuing to burn fossil fuels, and the atmospheric CO2 levels continue to rise at a steady, predictable rate. All of the scientific data says that the Earth is getting warmer and will continue to warm up for some time. The polar ice caps are melting, and glaciers around the world are receding. The estimates for how high and how fast sea level can rise if or when these sheets of ice melt are all over the board and depend on many factors that may come into play. If the oceans warm up, then there will be an increase in water vapor in the atmosphere. In addition, some scientists warn that there are massive stores of methane in the oceans that may be liberated into the atmosphere if the oceans warm up. Since methane and water vapor are greenhouse gases, adding more of them to the atmosphere could further accelerate global warming. Now, before we get all depressed about how global warming will end the world, let's take a look back in history. If we go far enough back in history, there was a time when there was a lot more of the greenhouse gases in the atmosphere, and the Earth was much warmer. Actually, for the entire Mesozoic period that lasted between 65 and 250 million years ago, the Earth stayed between 10 and 25 degrees Fahrenheit warmer than it is now, and CO2 levels ranged between about 700 to 2,500 parts per million. Now granted, life forms were much different then, and the dinosaurs ruled the world, but it does serve as a reminder that the Earth was once much warmer for a much longer period of time, and life survived and thrived through many periods of climate change. Now, I'm not saying that dinosaurs will evolve again and dominate if the Earth warms up another 10 to 20 degrees, but some species will go extinct, and others will survive. New species will also evolve to fill whatever niches they can, but it's impossible to know what they will look like. Maybe this time around, global warming isn't natural, and maybe we'll find a way to stop it from happening, or maybe we won't. Either way, life will adjust as it always has, and since humans are perhaps one of the most adaptable species on the planet, it's likely that we'll adjust too.